Good evening, friends. I'm Commander Atul Kumar Rohatgi speaking to you once again uh, in our series IIE Delhi HVAC Talks. Today's discussion is part of the series on psychrometry. This is the eighth in that series, and today we are going to discuss sensible heat factor. What is sensible heat factor? What is the importance? To define sensible heat factor, it is the ratio of sensible heat to total heat. Total heat is the sum of sensible heat and latent heat, and we can write it SHF is equal to sensible heat divided by the sum of sensible heat and latent heat. As we can see from the simple relationship that is in front of us, the maximum value of SHF is 1, and that will be when the latent heat is going to be 0. Where is this latent heat coming from? That is what we have to think. And what are those conditions where SHF can be equal to 1? Further thinking about it from the simple ratio that is there in front of us, we also see that SHF can also be expressed as the percentage of sensible heat as compared to the total heat. And if we talk about 1 minus SHF, that is the percentage of latent heat that would be present in air. The typical sources of sensible heat in a room are the sensible heat increases because of the boundary heat load, and boundary heat load comes in two different ways. It comes as conducted heat from all the boundaries that a compartment has, plus if the compartment has got a window through which sun rays are coming, then there is also some amount of radiated heat that is coming to the room. The next point could be sensible heat comes because of equipments that are present in the room, the equipments that have been kept in the room. If the room has got some computers, some servers, some desktops, a TV, or any other electronic or electrical item which is consuming some amount of energy, that will be emitting heat. The lighting load in a room will have lights, and the lights will cause increase in sensible heat. It is because energy cannot be created, cannot be destroyed. So whatever energy that is consumed for lighting the room, that comes in the form of lighting heat load, the heat load because of lighting in that room. And then human sensible heat load, the presence of human beings causes some amount of increase in sensible heat load of the room. So these are the four sources through which sensible heat gets added to a particular room. And now talking about the latent heat load, where does it come from? The primary source of latent heat is inside a room is because of presence of human beings. Human beings, when they are exhaling, they are they are emitting some amount of water vapor. They are causing some amount of water vapor to get added to the room air, and this water vapor is nothing else but the latent heat inside the room. Some rooms, not all, some rooms could also have water boiling equipments. Though those equipments like rice boiling equipments or tea making machines or sterilizing machine, uh, which could be there in a medical room, tea or coffee making machine in a pantry or in a kitchen, or rice boiler in a kitchen, dal boiler in a kitchen, they add latent heat. But remember, such equipments are not there in all rooms. So compartments that have only sensible heat could be, as we have seen where the sensible heat comes from, those compartments where the latent heat producing equipments or items are not there. So that will need to be a room where human beings are not there, and that will also be need to be a room where any water boiling equipments are not there. So what are those rooms? That could be server room, data center, switchboard room, etc., where human beings are not there, and also there is no water boiling equipment. On the other hand, or in fact, continuing with this, the compartments where the sensible heat load is high are those compartments where the number of human beings is very small. The compartments that have large amount of sensible heat in the room but have very little occupancy, or may not have any or very little amount of steam producing equipment, that will have I mean, such compartments will have high sensible heat. And the compartments that will have high latent heat load, a kitchen could have a high latent heat load. And in case if you are talking about manned compartments, then all places of assembly, they will have high amount of latent heat load. So these are a movie theater where a large number of people could be present, auditorium, indoor stadium, a classroom, a conference room, a place of worship. So those are the areas, those are the spaces which are likely to have high latent heat load. Now let's try to understand the sensible heat factor on the psychrometric chart. The sensible heating or cooling can be represented on the psychrometric chart with the help of a horizontal line. A sensible heating process involves horizontal movement to the right, whereas a sensible cooling process involves horizontal movement to the left. On the other hand, when we are talking about latent heating or cooling, a vertical movement represents addition of latent heat, whereas a downward movement represents deletion of latent heat. Now, when we talk about the combined effect of heat addition, sensible heat addition as well as latent heat addition, the sensible heat addition, the horizontal arrow is representing the sensible heat addition. The vertical arrow is representing the latent heat addition. And the resultant is being reflected by this hypotenuse, or the resultant line, which is starting from the initial point to the final point. Sensible heat and latent heat of a room, it gets fixed the moment the following things get fixed for a room. The moment we decide and fix up the room location and the boundary of the room, and the nature of activity that is going to take place inside the room, the number of persons who are likely to be there, and the number and heat load of equipment that is going to be kept there in that particular compartment. The moment these things are fixed, the sensible heat as well as latent heat of the load of that particular room, that gets fixed. And once the SH and LS, that is sensible heat and latent heat, gets fixed, the slope of the room process also gets fixed. For a given air quantity, this fixes the length of horizontal and vertical process and also the slope. So wherever we inject the air into the room, the rise in its temperature and the rise in its humidity content will always be as per the slope. And in case if this blue line gives the slope of the room process, then wherever we are injecting the air, we will always move parallel to this particular slope. So this is the importance of SHF. Though there is a lot left, we will continue with this discussion on sensible heat factor in our next discussion also. Thank you very much for watching it. This video came to you from ISHRAE Institute of Excellence. We are an HVAC training institute located in Delhi, and we conduct many online and offline classes as well as workshops. You can contact us on these numbers. We wish you all the best, and you come to us for starting an illustrious journey in the field of HVAC&R, and also you can come to us to upskill yourself if you are already working in the field of HVAC. Thank you very much.